Well, now we're finally going to take a look at these wonderful equations that are so important in mathematics and try to figure out how to solve them. Now, what does that mean to solve an equation? What we have to do is find out a value for the unknown quantity, that mysterious quantity that will make the equation hold true. And that means that if we think about the equation like a balance scale, that when we plug in that unknown quantity, the two sides will be exactly equal. They'll balance perfectly. If we're wrong, then in fact one side will be different than the other, and the scales won't balance. So our job is to find the solution and try not to be wrong. Now, how do you actually do that? Let's take a look at this example. Here I have x plus 22 equals 58. And the question is, what's the solution to this equation? Well, the mystery is x. Now remember, x, even though it looks like a letter, really represents a quantity. It's a number. And the question is, what's the right number to put in there so that this really is a solution? That is, the scales balance perfectly, and we actually see the same thing on the right as we see on the left. We get the same quantity. Well, the way to do that is to isolate the x, to get it by itself. Now the question is, how do I have x equals stuff? Here I am pretty close, because this says x plus 22 equals stuff. What I have to figure out is what x is by itself. I have to undo the adding of the 22. How do we undo adding 22? We subtract 22. So I want to subtract 22. But I just can't subtract 22 on the left, and that's the end of the day, because I take this perfectly balanced thing, and I'm going to take away 22. Holy cow! They're not going to be balanced anymore. To keep the scales of this equation perfectly balanced, I have to perform the same task on the right-hand side as I do on the left-hand side. So in this case, if I'm going to subtract 22 on the left, I have to balance that with subtracting 22 on the right. Now what happens when I do that? Well, this is easy, because 22 minus 22 is 0. So I'm left with x equals, and 58 minus 22, 36. And so there's the answer, x equals 36. Not sure? No problem. You can always check your answer by just substituting the 36 into the original equation and see if the two sides are equal. If you put in 36 here, 36 plus 22, in fact, equals 58. So it checks. And we found a solution. Let's take a look at this one. 27 equals 5 plus f. Now notice here the letter f is not x. That's okay. In math, we can use any letter at all to represent something that's unknown or a variable. In this case, it's f that remains a mystery. But we know that whatever that quantity is, it's going to satisfy this. That means that when you add 5 to it, it's going to equal 27. The question now is, how can I find f? I want to isolate it, and so I've got to say, well, gee whiz, I'm taking f and I'm adding 5. Undoing the adding 5 is to subtract 5 from the right-hand side. But wait a minute. If I don't subtract 5 from both sides, I'm going to lose this beautiful equality that balanced perfectly. So whatever I do to the right side, I must do to the left side. So I'm going to subtract 5 from the left side. And now we just do it. 27 minus 5 is 22. And 5 minus 5 is 0, and so all left is f. So f equals 22 is the answer. Don't believe me? You shouldn't. You can always check by taking this guess of 22 and inserting it back and seeing if it really is correct. If you put a 22 in here, 5 plus 22 does yield 27. This checks. And so we have a solution. This is a great way to solve equations that look like this.